So let's talk about solving large systems of equations in linear algebra. So let's say we have a system of equations like this, where we're trying to find x1, x2, and x3. We're trying to find what these variables equal. So what I'm going to do is solve this using a matrix. Now, I went ahead and put a 0x1 right here, and also I put 1s in front of the x1 and x2, because this will allow me to easily take my coefficients and plug it into this matrix. So first off, I can take all my coefficients for x1, then all my coefficients for x2, then all my coefficients for x3. And now I'm going to do an augmented matrix with everything to the right of the equal sign. So this is what your matrix should look like for this system of equations. Now, when it comes to a matrix, there are three rules. You can scale any row, you can add or combine any two rows, and you can swap any two rows. Now, oftentimes we'll do these two steps together, and I'll show you what I mean by that. So first off, what I'm trying to end up with is I'm trying to end up with a matrix that looks like one of these two. There's something called row echelon form, which is where you have this staircase pattern where everything beneath the staircase is a zero. There's another thing called reduced row echelon form, which we actually talked about in the last video, but for this video, I'm just going to try to get this into row echelon form. Now, the first thing I'm going to do is I'm going to take row 2 and row 3 and swap them, because that's going to give me this matrix where this 0 is now in the lower left side. So that gets me a little bit closer to this staircase pattern. But what I want to do is I want to end up with zeros here and here. So the way I'm going to do that is I'm going to start with row 2. I'm going to take -2 and multiply it by row 1 and then add that to row 2. Now keep this in mind. This row 1 here is to the left of the plus sign. This row 1 is not going to change, but row 2 is going to change when we combine things. So let me show you. If you run this operation, you should end up with this matrix right here. And notice that row 1 and row 3 both did not change. But row 2 changed when we did this operation. So we took -2, we multiplied it by 1. That gave us -2. And then we added this to this +2, which gave us this 0. Now we did that same thing throughout. So we took -2, multiplied by 3, but that gave us -6. And then -6 plus 7 gave us this +1. And we just kept doing that throughout this entire row. So now that we have this, I'm going to do this operation again, but I'm going to do it on the bottom rows because I'm trying to get a 0 right here for this 1. So what I'm going to do is I'm going to take -1 and multiply it by row 2 and add it to row 3. And since row 2 is on the left side of the addition sign, row 2 is not going to change. And row 1 is not going to change because it's not even in the operation. So row 3 is going to be the only row that changes. Now check this out. We're going to have -1 times 0 plus 0, and that's going to just give you 0. Then we're going to have -1 times 1 plus 1, which will give you 0 again. We're going to have -1 times 2 plus 3, which will give you +1, and then -1 times 11 plus 15, which will give you 4. So this right here is row echelon form. And now notice what happens if I take this out of the matrix and back into a system of equations. It'll look something like this. And now this is easy to solve, because all I need to do is take this x3 and sub it in here. 2 times 4 is 8. I subtract 8 on both sides, and then I'll get that x2 is equal to 3. Now I can take x2 and x3 and sub it in here, and that will give me these two variables. I trust that you can solve this one on your own here, and you should get that x1 equals 2. So now you have the three solutions for this system of equations.